Hi everyone and welcome back to Digital Design with Verilog course. So today we'll start with the exercise 3 and 4 solutions. Okay, so I gave you a few homeworks in the previous lecture about the exercise 3 and 4. So today we'll solve it. So the first question is very simple. What we have to do is we have to practice writing the following numbers: decimal of 1 to 3 in sized 8-bit binary format, and use this underscore for better readability, 16-bit hex and 4-bit negative 2 decimal number and unsized hex number. So I will move on to the code and show you the solutions basically. So let me move on to the codes. Just let me quickly run the solutions. Okay, so let me just show this. Okay, you guys still cannot see this now. Not this. Yeah, now I think you can see this. Okay, so yeah, that is the solutions basically. So here you can see, okay, this is the question 1. Okay, question 1. So I will just call the question 1, and like I don't think I have to explain this because much difficult things we have done this. Okay, so I don't think this is like self-explanatory. The first part was you have to use express 1 to 3 as a 8-bit binary number. So 1 to 3 in binary is 011 1101. You can identify, you can do that, but obviously you have to use underscore for better readability, so I used it. Then we had to write a 16-bit decimal number hx. So if I write tick h hex, then this will be totally unknown number. Then I have to write a 4-bit 2 decimal 4-bit negative 2. So how do you write negative 2? So like here, right, if you want to write a 4-bit negative 2, right, then you have to define the reg as a signed integer in the 2's complement form. So this is written in the 2's complement format. So I will show you the calculation as well. Look, let me go back and let me just show you the tablet. So if we have to write -2, right, in 4-bit 2's complement format, okay, -2. So how will I write it? First, due to this negative sign, first bit will be 1. Okay, first bit is always the sign bit. Then what is 2 in binary? 2 in binary is 10, correct? And as this is a 4-bit number, so 1 bit will be taken due to the sign bit, other 3 bit will be left, so we'll fill this with the 3 bits, so it will be 0 1 0. Okay, now I have to write this in the 2's complement format. So if I write this in the 2's complement format, first I have to take the complement, that will be 1 0 1, then I have to add 1, so it will be, if I add 1 with this will be 1 1 0. So ultimately my number becomes 1 1 1 0. This is what my number becomes. Okay, so that is what I have written there. And this last one is unsized hexed 1 2 3 4. So by default it takes the 32 bits size, right? So if I just show you the V's code, so if you see here that here it is showing, yeah, there's one. So like this is the number that I did, right, 1110. Now if I want to, if I print this in decimal, right, it will print -2. If I print it in binary, it will print this number only, because computer stores binary only. But then when it want to represent it, because it understands this is a 2's complement format, because I have defined it here, reg signed. If you remove this signed, right, it will be an unsigned number. By default it is always an unsigned, register is always an unsigned number. Okay, if I have to make it signed, I have to explicitly say that this is a signed number. Okay, so I will show you that as well. So let me like compile this. Before this I have to do cd in my location. So if I do cd in the location, cd this. Okay, now I have done the cd. Now I have to compile this. I verilog /o and the VVP file name. So VVP file name is, in our case, it is chapter 3 solution, right? So it will be something like not here, chapter 3 solutions dot VVP. Okay, that is the name. And my test, like what I am executing, I'm executing the test bench. So here, right, I will write the test bench name. So it will be chapter 3 solutions underscore test bench TV. Then I will press enter. So it will compile. And now if I want to see the output, okay, just have to do VVP and the name of the VVP file, chapter 3 solutions. Now you see, like here, right, what you are observing, that you're getting your C in decimal as -2, and in binary it is storing in 110 in 2's complement format. okay, and this is very simple. A is 1 2 3 and B was required to store as X, and D is 1 2 3 4 unsized hex number. Now what I want to do is, let me remove this signed sign. So what will be the output? What can you guess? What will be the output? The output will simply be a unsigned number. Okay, now if you observe, it is 14. So unsigned, it is 14. Okay, unsigned, it is 14. So I hope you understood this point, that if I don't write here signed, then it will not think it as a signed number. It will not then look for the first bit. Is it 0 or 1? Is it 0 or 1? It will include the first bit as a number itself. Okay, it will not think that the first bit is a signed bit. It will not understand that. Okay, unless I specify here red signed. Okay, so just be careful regarding that thing. This was the first question. Okay, let's now move on to the next question. Okay, let me go back to my tablet and explain you the next question. So if I go back to the next question, so this first question was pretty simple. The code is written over here. Next question, are these all following legal strings? Are these all legal? Okay, so this is pretty simple, right? This is a string displaying $sign. So is this legal? No, this is not legal, right? We cannot use $sign like this. How to represent $sign? I will discuss. Okay, is this legal? Yes, this is totally legal, because whatever I am writing, it will just print this directly. This is totally legal, but I cannot print $sign, because $sign is used in the inverted commas, right? For what? For identifiers, for format specifiers. So I cannot use $sign like this. How I can use? I will show you. Don't worry. Please ring a bell /007. So what will this do? This is totally valid. This will just ignore the slash. This will just ignore the slash. I will show you what will actually happen. The slash will get ignored. Okay, in the code I will show you. And is this a valid? This is a backslash character. No, we cannot use slash and then a space. We cannot do it. Okay, this is also invalid. So let's go to the code and check which one is valid and which one is invalid. So this is the question 2 basically. So if you see here, right, like these are the strings that was there initially. Just I have copy pasted the strings. Now this I told you option A is wrong. So if I try to print this, right, it will not print correctly. It will not print it. What it will do? It will just script. Not script basically. It will not show the dummy. It will not show the $sign. Like something weird has happened here. So how can I fix it? What is the correct way to fix it? So basically, if you want to print the $sign, right, you have to like write double dollars. If you write double dollars, then it will print a dollar. Okay, fixing option A. Fixing option A. So this is how you will fix the option A. So now if I recompile it, okay, you see now, if you see, the option A has been fixed. Like previously it was showing this, now it is correct. Okay, the option B was anyways correct. This is totally fine, and this was printing totally fine. No, nothing was the problem. Option B is also correct. It will just ignore whatever is after there in the backslash one value. So this, right, it will ignore this backslash. It automatically includes whatever there is after 007. It just ignores. Okay, it is valid. We can print it. It is valid, totally valid. Okay, next is the last one. How do I then print the backslash character? Again, you cannot print the backslash character. What you have to do is you have to simply write double backslash. If I write double backslash, then it will be fixed. If I write double backslash, it will be fixed. So now if I again compile it, you see now the backslash character is showing. Previously it was not showing. Okay, so that's how we fix it. Okay, so as explained from the exercise itself, that which options are wrong and which options are correct, it is done. Okay, so now let's move on to the fourth question. So what is the third question? Sorry, what is the third question? Third question is this one, right? Which one of the following are legal identifiers? So if I see, like this is totally legal, I can start with a S. Okay, after that there can be a number, that is totally fine. This is totally legal. This is not legal. I cannot start with a number. Okay, not legal. I cannot start with a $sign. That is specially reserved for system task. This is legal. $sign, I can end with a $sign. That is totally legal. So in the code itself I can show you that how which one is legal and which one isn't. So I think, yeah, here we have. So so one by one I will try to print. Okay, so let me call the module 3. Okay, mut let me comment this one out. Let me comment the previous module because we are not testing it anymore, we're testing the question 3. So let me do the compilation. So if you see, it is compiling, there is no error. Okay, so that's why it is totally valid, right? We cannot start with a number, except that it is always correct. Now if we start with a number, okay, if we start with a number, then it will crypt, it will throw an error. Okay, it throws error, syntax error, invalid module name. So here 32 invalid module name or something, it throws error. Okay, here if I start with a dollar sign, again it will throw an error because it doesn't like, it should be a system task, right? Latch is not a standard system task, so obviously we cannot start with a dollar sign. It again throws an error, but we can definitely end with a dollar sign. It will not throw any error. See, it does not throw any error, it directly executes. Okay, so I hope this one got cleared to you guys. So yeah, let's now move on to the next question. Okay, let's now move on to the next question. This should be, yeah. Just hold on. Okay, so let's now move on to the next question. If I move on to the next question is this one. Okay, so like it's a like pretty good question only, so I think you have tried to solve this. So here what we have to do, we have to declare variables in Verilog, a 8-bit vector net named in, okay, and then a 32-bit storage register integer, and this. So I will just show you like what we have to like do. So what I can do, right, can I show these side by side? I cannot actually, but like here only it has written like what we have to do, we have to show. So let me just uncomment the question 4. Okay, so it should be question 4 MUT, and this should be commented out. Okay, so now if I see, is first one was a 8-bit vector named in. Okay, it is a var, so it should be of net data type, so it is in. 8-bit means 7 through 0. Okay, it is done, simple. Next is a 32-bit storage register called address. Bit 31 must be the most significant bit. Okay, that means this is the point where I write the most significant bit, so this should be 31. And what they're calling, set the value of the register to a 32-bit decimal number equals to 3. Okay, so it is a 32-bit storage register, and we have to set this value to equals to 3. So we have stored the value equals to 3. So it is a 32-bit and it is stored as 3. So that's how we will set it. Okay, then we have an integer named count. This is an integer named count. We have to initialize, so we just initialized the integer named count. Okay, then we have to initialize a time variable named snapshot. So I write time snapshot, a time variable named snapshot. Then I had to initialize a array called delays. Array contains 20 elements of type integer, so it has 20 elements of type integer. Okay, and like this is the MSB, this is the LSB, but generally what we do, right, actually we write 19 here first, then 0 here first. That is the trend generally, but we can write 0, 19 as well, but then the how you access the array becomes different. So I will follow our convention. 0, 19, this is the MSB, like highest element, and this is the lowest element, that's it. Okay, and this is the array delay, which has 20 integer elements. Okay, each elements are integer. Next one was a memory mem containing 256 words of 64 bits each. So each element of memory has 64 bits. Okay, and how many memory, like how many types of this 64 words, 64 bit words I have? 256. So it should start from 255 to 0. Okay, so it is a memory named mem containing 256 words, and each word has 64 bits each. So that's why it has 64 bits each. Okay, next one was a parameter named cache size, who equals to 512. So that is what we have done, equals to 512. So that's how you can declare. So like you can compile this code. Okay, it will not throw up any error. If it does not throw up any error, that means whatever you have written is totally correct. Okay, so that's how we can verify that whatever you have done is correct. That's how you do the question 4. Okay, so now let's move on to the next question. So if I move on to the next question, so the next question is this one. What would be the output slash effect of the following like codes? Okay, So this question is again like bit interesting, so you have to tell about the output. So now here latch is equals to a 4-bit number 1 2. Okay, so is it a 4-bit? Yes, it can be a 4-bit number, that is fine. 1 2 in decimal can be a 4-bit number. Display the current value of latch. Okay, what would be the output slash effect? So the current value of latch, this is printing in binary, so I have to write in binary. So if I write in binary, it will be 1010, I think. So this is 8. Okay, no, it will be 1100. 1100. This will be 2 raised to, like, this will be 4 plus 8, that is 12. Okay, this one reg 3 bits of 2 monitor, and this reg 2 colon 0. Now like this reg is of 3 bits, right? But like assumption is like we have enough size. I'm accessing all the bits, so basically what it will print, right? In binary it will print simply 10, that is my expectation. And this one is define mem size 1024, so the memory size it will print in hex, right? This, right, is by default it assumes it to be in decimal. It assumes it to be in decimal. So in hex what it will be? So like this is like what, this is simply 2 raised to power 10, right? So the 11th bit will be high. If the 11th bit is high, that means 11th bit, so this will be 0 1 0 0, then 0 0 0 0 0 0 0 0. This is the 11th bit. Yeah, 8 9 10 11. Yeah, so basically now if I convert it to hex, so this will be this will be 4 0 0. So output should be 4 0 0. So let's check what we are getting as the output. So I have the code here, so let me uncomment this thing out. Okay, and then is the question 4. So let me compile this. Yeah, so what were we expecting? We are expecting 1100, as I can show you. Like we are expecting 1100 from this, we are expecting 1100. Okay, and then we were expecting 10. Okay, 10. Am I not printing that? Okay, actually the thing is here, right, it doesn't print 0 in register. So okay, yeah, it prints 10. Yeah, it prints that. Ignore this line, this line is for something else. Ignore this line. First I was expecting 1100, so it printed 1100. Then I was expecting 10. Why is it printing it here? Why is it printing after this? That is my doubt. Okay, because there is a like macro, right? That's why I think this will be evaluated first, then this will be evaluated, because this is monitor statement. After it changes the value, then only it will be printed, right? That's why. So what happens, it directly prints this one first. Mem size we are expecting 400, which is what we are getting, 400. And as it is a like a 32-bit number, that's why like it prints the other bits as well. Okay, and this is what we expected, 10, and we are getting 10 only. So whatever we expected, we are seeing the output. Okay, this here written H400 100 1100. Okay, so whatever we expected, we are getting the same output. So whatever we have written is correct. So I hope you have understood the questions. Okay, so now let's move on to the other module, to the exercise 4. Okay, so I will open the exercise 4 solutions. Let me open the exercise 4 solutions. Okay, so if I open the exercise 4 solutions, so we like first question is, what are the basic components of a module? So like this is like a theoretical thing, so already it is written over here, like the what are the basic components of a module is a keyword, like what are mandatory components. This I have explained, but as this is a theoretical thing, so just theory answer is there, so that's why. Next is, does a module that does not interact with its environment have any IO ports? Okay, so will it have any IO ports? A module that does not interact with its environment will not have any IO ports. Okay, so does it have a port list in its module definition? No, there will not be a port list, because it does not interact with a its environment, external interface. Okay, now let's do the third question. Third question is from where the numericals start. So we have to design a 4-bit parallel shift register that has IO pins shown below. One is the reg in, another one is the clock. Write the module definition for the module shift reg. Include the list of the ports and declaration. You don't need to show the internals. So they're just telling you to write the definition of the module. Module internals can be left for now. Okay, so let me just show you. Then what they are telling, then next steps they are telling, we will come to the next step. Let me first show you the question 3 for now. Okay, so if I move on to the question 3, so this is just the module. I'm not showing the module internals, I'm just showing the module working. Okay, so like this question 1 can go away. So here if you see, just I have defined the module name named shift register. It has 3 ports. One is output port, that is reg out, which is a 4-bit, and one is clock input, another one is reg in. Okay, these are the outputs and inputs. So in the question 3 they have just told us to define this. Now let's come to the other part. So if I come here, then they are telling me declare a top level module stimulus, define reg in 4-bit and clock as register variables, reg out as wire, and instantiate the module shift reg and call it SR1. Okay, so basically they are like trying to make a test bench. So they are trying to make a test bench. So that is what we have done in question 4. So if we see in question 4, that is what we have done. Basically we have defined a module stimulus which has a register named regin, 4-bit register, input register, then a register named clock, then a wire named reg out, because they have mentioned that the output should be a wire and the input can be register variables. Okay, so that's what they have mentioned and that is what I have done. Then I have instantiated the module shift reg from here, and the name of the instance is SR1. Okay, and then I have connected to the ports. Okay, by ordered list. If it was unordered list, then I would have used dot operator, but they have specifically asked to ordered list, so I have done ordered list. So that is the question 4. So now let's move on to the question 5. Connect the ports in step 4 by name. Okay, now they are telling me using unordered list, right? So if I connect it using unordered list, this is how we will do it. Everything will be same, just when I will connect, right, I will connect like this: dot clock, clk, dot regin, dot reg out, just like that. So everything will be same, that's it. So this is the question 5, basically very simple. So let's move on to the last part. Write the hierarchical names for variable reg in, clock and reg out. Okay, so we have to write the hierarchical names. So how what are the hierarchical names? So again, if I show the code, this is the question 6. So the hierarchical names will be this, right? Stimulus.regin, stimulus.clock, stimulus.reg out. Okay, this will be the hierarchical names. Very simple, right? Just stimulus dot, if I do dot, then I get to the regins. This already I have this concept I've already explained previously as well. Okay, so now will not explain it here again. So next what they are telling me, next question is write the hierarchical name for instance SR1. Write the hierarchical name for its port, clock and region. Okay, so here if I see, here I have written the hierarchical name for let me comment this thing out. This is the hierarchical name for the instance SR1. So I'm inside stimulus, right? So I have to do stimulus. Stimulus is here. Okay, this is the module stimulus. So I'll call this module stimulus.sr1. Inside this I have a module named sr1. So that's why stimulus.sr1. Now if I want to get to the ports, so that I have to do stimulus.sr1, then I have to do dot clock and dot region. Then I will get to the ports. So that is how you do, basically. Pretty simple. So like that was about all the questions. Like I think it was not that difficult for me to explain the questions. Questions were pretty simple. Like the this first two exercises are very, very simple. You don't have to implement the shift register. We'll implement it later on. We'll implement it. You don't have to worry about it. So that was it basically for this lecture. This lecture was pretty easier only. So in the next lecture we will learn about gate level modeling. Okay, we'll start with gate level modeling, then we'll go to the data flow level modeling and behavioral level modeling. So yeah, Thank you for watching, and I hope to see you in the next video. Until then, happy learning.